Well, good morning, everybody. My name is Stephen Cope, Compliance Manager for Mayer Timber. And I'd like to introduce my colleague, Julie Hargreaves, who works for Lonza Timber Protection. And whereas in the previous presentation, you were looking at a manufacturer acting on his own and doing everything that was necessary to get his product to market in legal compliance with the CPR. In the case of Julie and myself, we are two separate legal entities acting in a partnership. Together, we are the manufacturer trying to achieve the same result for our customers as my colleague David is achieving for the Smartfly customers. We as Mayer Timber place the product on the market, but we don't do the clever stuff. That's done by Lonza. So first of all, I want to pass you on to Julie Hargreaves, who is their resident chemist, to talk to you about the clever things they do to get the product, the chemicals, into our product.
Okay, thank you. Good morning, everybody. So, as with David, I'm going to focus primarily on one of our products, which will be Drycon fire retardant, which is an internal fire retardant, one of two that Lonza produce along with ATP generic. What I've done is split the process down into 6 stages, and I'm going to talk about each stage in more detail. But first stage will be the specification, and that is, for me, is the most critical part of the process, is getting the specification right before we go on to produce fire test work and produce the final product. I'll then talk about how we prepare the fire tests, and in a similar way to David's product, we're following the same pattern in terms of the test work. The difference is our product is applied after the wood is produced. Just gives us more flexibility in terms of we can treat lots of different species and lots of different commodities in a more bespoke manner. We then go on to produce the fire test reports, and again we're using Exova Warrington, probably one of the most respected fire test houses in Europe and probably globally. So that gives us confidence in the reports that we generate. I'm going to talk about how we produce the chemical at our factory in Huddersfield, and then finally on to how we process products such as the panel products coming from Mayers. And just to close the final loop again, just to show you how the external bodies come in and audit that process and give you assurance that we're controlling that process as well. Drycon's been around for quite some time in Europe and also in America, and still a live product in both continents with over 40 years commercial experience. So it is tried, tested and proven in the marketplace. So moving on to the first stage, which is the specification, and this generally isn't something Lonza do. This is coming from the architect or the fire engineer. So they're going to come to us or come to our client and say, you know, this is what's required in terms of the specification for that piece of timber or that product. Again, that really depends on where the end use is, what the intended risk is in terms of liability of the building. There's a lot of debate at the moment around high-rise buildings and whether these additional facade tests are needed. But essentially we are also following what's required by the architect in terms of complying with the building regs and allowing us to then pass on the information to the end user so they can complete their CE marking. There's also different industry standards. So in the rail sector, they would require additional testing, particularly if you're in sort of a tunnel environment or an enclosed space. You've got more risk with things like smoke and toxicity. So there's the standard tests. But essentially, these are the basic requirements. What we need to know at Lonza in order to take that forward into a fire test is what species you're intending to treat, what thickness you want to treat, and also the density range. So the tests we do are species specific. We will generate test reports per species. I can show you how we can group some of those as well. But essentially, we do the test work per species to give you a valid test report and test data. So generally people now are following the Euroclass, as Gordon outlined earlier, Euroclass B or Euroclass C, depending on the end use. Within that, you have the various tests that were outlined earlier. You've got the reaction to fire test with spread of flames. There's also a smoke test within that suite of tests, and sometimes the amount of smoke generated can be part of the specification. Probably doesn't tend to be so critical in the UK, but certainly in Scandinavia, a lot of fire specifications would include a smoke classification. Seeing less and less of the British Standard specification come through, but that's still live in a lot of contract specifications, so we are still seeing that come through quite a lot. And finally, what is the service environment, the intended use for the material? There's a new standard in town, the EN 16755 fire durability, and this relates to, as it says on the tin, the fire durability of that product in use. You'll see the terminology they use there is, which you may be familiar with, it refers to interior dry environment, which has the classification INT 1. If the product's going into a humid environment, it needs to be a higher calibre product, and that's referred to as INT 2. Or if it's going external, it would have the terminology EXT. So we need all this information before we start to plan and prepare timber for a fire test. So the example I'm going to use is to say somebody specified a Euro Class B, maybe not too bothered about what the smoke classification is. They want to use the Drycon product and they want to achieve INT 2, which is the interior humid environment. So we'd then move on to do the EN 13501, which is the reaction to fire testing suite. And as we've already seen on the videos, that includes carrying out single burning item test, which is where you set fire to a panel which is supposed to be simulating a small fire in the corner of a room. You actually need to submit and pass 3 tests with that SBI test. So generally the standard asks you to submit 5, and of that you have to pass that test reproducibly 3 times. And in addition to that, there is the ignitability test, which is the small flame test, which pretty much most products would pass that quite easily. So that Euro Class B test is specific to that species of timber with Drycon incorporated into it. And what we do in our test facility is just optimise the amount of Drycon and how we get that product in there to achieve that Euro Class B. In terms of the fire durability test, which is quite a new standard that's come in last year, internal 1, if you need to achieve internal 1, then all products would get an automatic classification for internal 1. To move up to internal 2, which is the humid environment, you need to do an initial test on your product. And that is specific to the fire retardant product, not actually specific to the species. Basically, you're putting your product into some pine and putting it in a very humid environment and trying to see how much moisture it picks up. And there's a set point for the amount of moisture pickup you're allowed in a product, which is the threshold of what we call hygroscopicity. If you're moving to an exterior product, there are additional tests on top of that, which means you'd have to do what they call accelerated weathering test, which is a small fire test called a cone calorimeter. So you would test your product as it is. You would then take a match sample of those samples and you would expose them into an accelerated weathering machine, which basically exposes the product to ultraviolet light, humidity, which is simulating spraying rainwater onto the panel, and this is a cycle that you submit the panel to for a period of 12 weeks. And after that you retest your timber and see what the downgrade is on that, and that's how you generate a certification for your fire durability. So you're trying to simulate how that product's going to perform in an exterior environment. We have research and development facilities at Castleford, and we have pilot plants. There. But when we move on to generate certification for a customer, what we do is actually like to produce the certification based on the full-scale production facility. The whole test sample regime is controlled by the technical centre, so a team of chemists there will literally weigh hundreds of pieces of board, number them and follow those through the treatment process and verify that the exact product retentions that those boards have achieved. So they can then prepare the boards to send off to Warrington for testing. And again, in a similar way, that will then, hopefully if they pass, if they don't, we'd have to do some modifications, but once they pass, that would generate the fire classification report. The field of application, I think, Stephen, you're going to cover this a little bit in your talk. Yes. The field of application does need some consideration. So before we put the final panel together, we need some discussion with the customer. How is this product going to be applied in the end use, in terms of consideration of what backing materials would be used? Will the backing materials be Class A? Would they be Class D? Would they be non-combustible, or could they be untreated wood? Would they be installed with or without an air gap? Most products we would tend to try and test with an air gap. Air gap is the worst case. If you imagine you get some burn through of that panel, if you have an air gap, then effectively you've created a chimney, which can help to accelerate the fire. So if you test with an air gap, you automatically, if you pass that, you get a certification for with an air gap or without an air gap. If you only test without an air gap, you cannot go upwards to have certification with an air gap. Other considerations, like any membranes that are going to be installed in that construction, and if there's an intention to apply a coating afterwards onto that substrate, then the whole system would need to be tested with that coating. So it would need to be a fire retardant based coating. In terms of once we've got a classification report, what we'll have done is done the testing at the minimum thickness, which actually is the highest risk in terms of reaction to fire. So if you imagine a very thin piece of timber with a flame on it, it's going to react with fire a lot quicker than a very thick piece. So if we only tested at the thinnest level, so if you look on this diagram here, species A, if we've tested a 10mm board and we've got a product retention of 25, if we'd only tested at that single thickness, we would then have to test, if we treated any timber higher in thickness, everything we treated would have to be done at 25 kilos. What we actually find is and the correlation is the thicker you go, the less chemical you need to achieve the same Euro class. So commercially, it doesn't make sense to add a lot of chemical to thicker boards. So what we would do is test at a higher level of thickness and generate an extrapolation so that we've got a correlation and we can then treat a range of the chemicals. We said reports are specific to the species. So as an example, if we had classification reports for European oak, and then somebody came to us and said, but I need to treat American white oak. Different oak species have different densities, and therefore that needs consideration. So we have tested American white oak and actually added it into the European oak specification, but you cannot assume that even two species of oak would perform the same. You do need to verify that with some test work. So moving on to producing the chemical that we use, how we produce Drycom. First of all, we work under ISO 9000 quality systems, so all of our materials and our suppliers are vetted. Any changes in raw materials or changes in suppliers have to go through the quality system and some testing in the QA test laboratory. We have a bespoke manufacturing site in Huddersfield, which is where we produce all our fire retardant chemicals and also all of our preservatives. It's a fairly state-of-the-art chemical production site. It's actually a coma site, and that operates under the ISO 9000 quality scheme. It's also ISO 14001 certified by BSI. The actual process of producing the timber is a full impregnation. So when timber arrives on site, first of all, we would check the moisture content to make sure that's within set parameters. If the timber's too wet, it's not going to accept the chemical loading that we need to achieve the fire certification. So once that's been verified, this is the process that we use. So first of all, a vacuum will be drawn, and this serves to evacuate the wood cell structure to remove any excess moisture in there. And that means that the wood is then accepting of any further chemical treatment. So this is a full autoclave picture up on the top right, showing the timber going in. So we then flood the vessel with the chemical, and we apply a pressure. And the pressure cycle is controlled, and it's specific to the species and how we've produced the test data. And that could vary from three hours down to 30 minutes, depending on the type of timber that we're treating, or the plywood or the board. After the treatment's completed, the vessel's emptied, and we pull a final vacuum, and this basically evacuates any excess liquid from the timber. And then as the timber relaxes, the low pressure within the timber then just draws a small amount of that fire retardant into the solution. The benefits of impregnation are, first of all, we've got a fully controlled treatment process, so we've got full traceability of how that timber's been treated in terms of the application of the chemical, the process conditions. The pregnation treatment will go in, because it's full immersion, will go into all faces of the timber. So in comparison to maybe a surface treatment, you've got like chemical fully into the timber structure. So if there was any sort of damage as it was being put on site, you've still got that integrity of the chemical in that treatment. So as we receive an order through from the customer, we start a chain of custody to track, and this helps Stephen with his CE marking. So a label goes on with a unique customer identification and the order number, and that's tracked through the whole process until the timber leaves site back to the customer. Various process quality checks are carried out on site. This includes checking the solution quality, process parameters. Anything that can be calibrated will be calibrated, so flow cells, load cells, temperature, pressure conditions, all of those are monitored as part of the ISO 9000 system. The actual treatment process is automated, and I'll show you how that software works. But we also do a cross-check of the pack weights as well. So 20% of the packs will be manually weighed to cross-check that the software is accurate. Lonza have developed their own software to carry out that treatment, and it's called Auto Treater. It's what we use for fire retardants. It's also what we use for preservative chemistry treatments. The specifications that are fed into that system are controlled by me and by the technical centre. So any changes or any authorisations are a controlled issue to the software system. The system cannot undertreat, and the operator has no authority to override that system. So the best they can do is overtreat. That's all they can do. So there is no fail-safe. There's fail-safe in the sense that they cannot stop a treatment early. If they fail to reach the required retention, they would have to treat again, so that they actually reach what's required for the certification. Daily checks are carried out on the quality in terms of the strength of the chemical, and you can get slight fluctuations in that from day to day. So that figure is fed into the software, so every day the software is adjusting to take account of the strength of the solution that you're treating with. And finally, the timber goes into the kiln. Again, all the kilning process is controlled and monitored. That typically can take up to about 5 days to complete. And that's the finish of the treatment for the customer. Under factory process control, we have a number of audits in a typical year. So the main one we have is a visit by Exova Warrington, which is the annual factory process control audit and sampling of the process. We also have visits from BBA, so Drycon is BBA approved, and they do an annual site audit. In addition, they'll do a 3-year full desktop audit as well. The process and the site are covered under ISO 9000, so we have biannual visits from BSI And also part of the technical team function is to go into production and do some internal audits of the process. And finally, we have the WPA approval as well. Just as an example, that's our latest Exover Warrington factory process control certificate, which was issued last month. So I'm just going to hand over to Stephen now, who'll complete.
Thank you very much. I did say that was the clever bit. What we do is now place the product on the market, and to do that we have to go through the documentation to make sure that what we're getting is precisely what we're going to say it is to our customer. Now, for most treatments that anyone will do for you, they will give you a treatment certificate, and it tells you a number of things: what process was applied, who the customer was, the batch number, when it was treated, what was treated, the performance to expect, who applied the treatment. It does not tell you any of those things. So if the process was tested, it doesn't tell you when it was tested, by whom, what the test results were, if your purchase was indeed from that batch, or if your purchase will even perform as claimed, or if your intended end use is within the field of application of the product if it was tested. Okay, so a treatment certificate is just a claim. It doesn't constitute evidence on its own that the treatment works, of the field of application, or the product was placed on the market legally. Legality requires evidence, proper testing by authorised test bodies, and an audited factory production control process, not only in the factory where the process took place, but in our warehouse, to show that we can trace the product all the way through the supply chain, from the time we send the material off to be processed to the time that we send it to the customer. And then we have to declare the performance of the product, which may be performances in addition to some of the characteristics you'll find on the treatment certificate. Now, what I want to do is to cover some of the legal validation for this process. David Murray referenced the Construction Products Regulation. I want to point out to you the particular terms that are relevant to this particular process. First of all, it says when a construction product is covered by a harmonised standard, a declaration of performance shall be drawn up. So it must be drawn up if a harmonised standard exists for the product. It obviously does, EN 13986. So to place that product on the market, a declaration of performance is a legal requirement. Similarly, once the declaration of performance has been drawn up, a CE mark must be placed on the product. Both the declaration of performance and the CE mark will give you a very good indication of where and where you can't use that product, not just the fire classification that was achieved in test. To help you pick through the detail, EN 13986 has a natty little table of bits and pieces, which I'm going to point out to you now, in Annex ZA. It calls up all the classifications found in EN 13501. It calls up the systems of assessment called up in the Construction Products Regulation. And it shows those specifically for the reaction to fire classes in both structural and non-structural products. Now, here's the rub. I don't know whether you can see it on the screen, but against those reaction to fire classes, there's a single asterisk. It's probably the most important asterisk in the entire document because it refers to that footnote. And just in case you can't read that footnote, there it is. So, products or materials for which a clearly identifiable stage in the production process results in an improvement to the reaction to fire classification, e.g. addition of fire retardants. That's precisely the product we're talking about, and that is the validation for the argument that System 1 must be followed when putting this product in the market. So where do I find System 1? Okay, well, luckily for us, that's also contained, there's a reference there, I don't know if you can read it, but it says CPR Annex 5, Section 1.2. So if we race off to that particular part of the CPR, there it is. And it defines the role of the manufacturer, bearing in mind in this case it's Julie and I working in partnership, in a collaboration, to be the manufacturer. We both have to do what is required where it is possible. We both have to have factory production control processes that are audited by a notified body. But also there's a further testing of samples required at the factory. The factory is Julie's factory. I don't have a factory, so I can't take the test samples, obviously. But also it says in accordance with a prescribed test plan. That means there must be a test plan. Okay? So testing is continuous throughout the production of the range of products treated in their plant. The second bit is to do with the role of the notified body. They have to issue a certificate of constancy of performance based on determination of the product type. That's the initial type testing that Julie and Lonza carry out that result into a classification report. That's the next important document for me because I'm going to be using that when developing my declaration of performance. Initial inspection of the production plant, that's both our warehouse and Lonza's factory. Both are audited initially, and continuous surveillance of both sites. So we have to act collaboratively as the manufacturer. Now, as a result of the tests that are carried out in the initial type testing, we get a classification report, and there are certain things that this report must show. The name of the notified body that issued the report, the name of the entity who commissioned the test. You can see it was Arch Timber Protection, a brand owned by Lonza. Who prepared the report? Warrington Fire in this instance. The notified body's official number. What was tested? In this case, I'll read it for you. That's Far Eastern plywood with ATP generic flame retardant. The classification report number, that's useful because we're going to reference that on our declaration of performance. The date of the report is also important. At the end of that report, we're going to get a reaction to fire classification. This is what we will transfer onto our declaration of performance, and this report provides the evidence for it. It also shows the field of application, that this particular product is intended for non-structural use. It has to be mechanically fixed to an A2 substrate, which means there will be no air gap between our product and whatever it's fixed to. There are other reports for other thicknesses and other products where an air gap is permitted, but this is just an example of how we get to where we need to be. It gives the minimum input requirements for that process. In here we're saying Far Eastern plywood. In practice that normally means Malaysian. Anything from China won't have the bonding requirement and has every capacity to be affected in the plant. And Indonesian material tends to be so dense we can't get the chemical into it anyway, so Malaysian product tends to be the default input requirement here. This particular classification covers a wide range of thicknesses and a wide range of densities of product. And finally, the name of the issuing officer. All that information is important to me when drawing up my declaration of performance to give to my customer. Along the way, I too have to have a certificate of factory production control, and it must show who the notified body is and their registered number, the nature of the certificate number, which is specific to me and my range of products and the notified body. The scope of the performance is covered by the certificate. If anybody wants a copy of that, they're welcome to it. It gives a whole range of scopes. And I'm just focusing on one at the moment, which is relevant to the classification report I showed you. It happens to be that one. And in that, there is the scope of the certification, including the field of application. So it is Euroclass B for internal use as a non-structural component. Finally, the name of the entity placing the product on the market, and that's obviously Mayer Timber. It also has to show the locations where the audited activity takes place. That shows the collaboration between Mayer Timber and Lonza Timber Protection appearing on the same document. It shows the harmonised standard governing the activity, EN 13986, and the name of the issuing officer with the dates of issue and expiry. All of that information allows us to put together a declaration of performance. Now, I'm sure you can't read too much of that detail on the screen, so I'll try and point it out to you. There is the unique reference number of the DOP. That is specific to Mayer Timber. You shouldn't find that reference number on any other DOP. There's the field of application of the product declared, okay, which is internal use in dry conditions as a non-structural component. All of our product codes on our computer which are covered by that declaration of performance. The end use, the intended end use of the product. Who placed the product on the market? That's us, obviously. The system of assessment that was applied to that process, the notified body, and what they did to help us get this product on the market. Finally, it must show the declared performances. There is the reaction to fire C. There's a reference to S2, which is the smoke output during combustion, and D0, which is the extent of the burning droplets which could arise in the event that a fire actually took place. There's a reference number of the original classification report, so this refers back to the specific report that we used to get all the data we needed, and that is signed by a director of the company, and that allows us to place the product on the market. And then finally, that leads us to the CE mark. So, looking a little bit closer at the CE mark, there's the CE symbol, there's the unique reference number of the DOP. This is the product that is either, this is a mark that's either on the product, on the packaging, or on a document associated with the product. Anyone who buys one of these products from us will find a reference to the DOP on the delivery note. That's a reference to us. That's a reference to the last 2 digits of the year in which we first put this mark on the product. The standards whose requirements are satisfied by virtue of all the work that we've done, the declared performances, and the end use and the field of application. As a result of all this effort to tie together all the documentation to give our customers the assurances that the products we place on the market will do exactly what they say, we have certain deliverables. This, for me, is all about quality assurance. We want our customers to be completely confident that anything they buy from us that we're making a reaction to fire claim to will do exactly what it says on the tin. And with a declaration of performance, that provides you with a provenance that you can pass on to your customer. If you want a copy of the Certificate of Factory Production Control, you can have a copy of that as well. The product information gives you intended end uses and fields of application. That comes with the product as well. And finally, it's about legality, DOPs, CE mark, confidence that the CE marking requirements have been met in every stage, in every way. And all our DOPs are available on our website. And also there's a URL for each DOP, as I said, included in the delivery note and on the invoice every time you buy the product. Finally, this is all backed up by instant availability. Because we have these products in stock, you can buy today and receive them tomorrow. You don't have to wait for them to be treated. They're there waiting for you to buy. Thank you very much. Well done.